Hello, good morning, good afternoon, good evening, depending on where you are in the world. Thank you very much for making the time to listen to this webinar. Hopefully you'll find it interesting, informative, hopefully learn something, and hopefully have a few questions at the end of it, because I'm not here to answer absolutely everything. It's a topic that is ever evolving and ever growing. So I'm Matt Beale, and today we're going to talk around AI ethics and how it's actually important for everyone within the AI lifecycle. We're going to give you at the end of this 4 steps that you can use when developing AI solutions, whether that be hands-on or at a more management level. And these steps come from the experience that we have with customers, what makes them successful, and lessons we've learned from within the industry as well. First off, a little bit about me. I've spent 10 years within the IT sector. The first part was helping multinational customers and public sector organizations move workloads into the public cloud and optimize those public cloud environments. More recently, I've transferred over into the AI and machine learning space, and now I advise customers on how to scale models where they might have a small proof of concept or a proof of value they've built internally, but they want to bring it out into production, whether that be through labeling, through machine learning strategies, or whether it be model development. All of that is part of my remit. And I've covered autonomous vehicles, geospatial, medical AI, retail, and financial services within here. Hopefully, I can at least give you some advice from some of those spaces. Hopefully, some of those resonate within you. And just because you aren't from one of those areas that I've just mentioned, doesn't mean this isn't going to be relevant to you. What I'm going to talk about here is very much a generalized topic across all areas. It isn't pertaining just to one area over another. So this is quite an interesting question, because when you ask someone this, pretty much everyone says yes. I actually asked this very question at ODSE earlier on this year because I was presenting there, and it probably won't surprise you too much that every single person in the room put their hand up, and everyone likes to think that they're a good person. And I'm sure everyone who's watching this equally would like to think they're a good person. I'd like to think I'm a good person, and we do everything ethically. There is a big challenge though, because the reality is not everything is perfect. I'm sure you can think of countless examples where someone or something hasn't been done completely ethically. But what do we mean by ethics? So this is a very interesting piece, and I've got the Oxford English Dictionary definition up there for you, where ethics is a set of moral principles, especially ones relating to or affirming a specific group, field, or form of conduct, which, as the OED is quite a lot of the time, is wonderfully wordy. I actually distill it down. I try and make things nice and simple because there's far too much complex going in the world. We might as well try and make stuff as simple as possible. I find there are 3 main principles when it comes to talking about ethics, and we're talking ethics generally here, not within just the realm of AI or even not even within the realm of IT. We're talking generally ethical practices. They're defined by being truthful, the correctness of something, and the sincerity of something. If we lose the truthfulness in something, it's very difficult to be ethical. There are cases where you could probably argue it might be possible, but it's certainly not easy. Being correct about something, that's also important. And there is a difference between doing truthful and being correct. One is empirical and one is subjective. So we want to be subjectively accurate, but also empirically accurate as well. You also need to be sincere, and this is where it gets into more emotional understanding of what we're trying to do. You can be truthful and correct and insincere with something, and most of us would say that's probably not an ethical thing. When we take this and distill this down into the field of AI, and actually we look at some of the industry leaders within kind of that space. Take Deepak Arwal, who's one of the former VPs of AI at LinkedIn. He says that no matter how hard you try, there will always be some inadvertent bias. So does that mean that we just give up and there's no way of ever solving this problem? I disagree with that. I think that we very much need to be involved with this. Yes, there might be some inadvertent bias, but it doesn't mean you can't combat it. And we're going to look through how that can be inadvertently put into a system and what we can do to help manage it and try and remove as much as possible from that system as well. So why should you care? Because at the end of the day, if it made no impact to you, then there's going to be no real importance to you. So we actually ran a study earlier on this year, because this is very much a topic that's kind of integral to kind of CloudFactory and what we do. And we actually found that 89% of IT leaders said the ethical stance of an organization they're working with would influence their ability to work together. So this is going to be doing stuff like impacting purchasing decisions. It's going to be impacting what technology gets used. It's also going to be impacting growth of businesses. And I think it's fair to say, and I think everyone in this room probably wouldn't be surprised with it, that to grow a business today, you're going to need to leverage AI in some sort, whether that be an AI decision-making as part of your process, whether it's going to be augmenting a customer support function with AI. There is going to need to be that. Within a lot of countries in the world, there is a big crunch for resources. And I'm not talking necessarily just natural resources, I'm also talking human resources, people to staff in quite a lot of places. So that being said, once again, stat probably won't surprise you, but 94% of organizations have had some increase in AI deployment in production in the last 2 years. We've moved away from AI being something that a couple of people are just playing with in the corner to it being center stage of a large amount of businesses across the world. And that is only going to be something that grows. And if you looked at that stat a couple of years ago, you'd probably be somewhere in the 70s or 80%. But 94%, we're talking nearly every single organization is having some form of increased AI deployment. There is a challenge though, and this is a really big thing. 94% of IT leaders also believe AI is biased. So if something is biased, but the ethical stance is important, you end up with very much a dichotomy there, where something is doing something that we'd probably all think is incorrect. And if a system is biased, you probably aren't going to think it's an ethical one. So this leaves us with a real challenge where it's not easy to create something that is successful. There are countless cases, and some very famous ones, of bias being put into AI systems, generally inadvertently, generally perfectly innocently. But it is the case. We've got stuff like Tabot that exists. And if you haven't read about it, I would encourage you after this to go and do a quick Google, search Tabot, and read the very short but very impactful history that had, because it's very interesting and it's a really good kind of anecdote to use in these kind of pieces. I'm not the first person to talk about AI ethics. I would hope you've at least heard the term before. But typically, the conventional focus has been in the end phase of AI development, when we're talking about refining and optimizing a model. So there are 3 phases where we have design and build, deploy and operationalize, and refine and optimize. Underneath that, there are actually 7 steps, going all the way from data acquisition at the very beginning to model optimization at the very end. But the conventional focus has only been on those final 3. It's been validating your model. It's been on automating exception handling and model optimization. It's been a very model-centric approach. And whilst that has some uses, it's certainly not the best way to be going about this. Actually, what we want to be doing is looking at the real scope of everything. And I will show you a few examples how a failure in an early area can actually cause a real problem. Some of these are real scenarios, some of these are slightly fictitious, but certainly useful for kind of showing you where these challenges are. A really quick, useful example, any of you who are in the US will probably resonate to this quite a lot. US healthcare data is not the most unbiased thing in the world. This is not saying the US healthcare system is broken or there's a big problem with it. Just if you look at through history, there has been biases to certain demographics, and that is just the case. It's the same in many other countries. Just the US healthcare system has one of the easiest ways to be able to access a lot of that data and be able to build on it. The challenge is, if you're using that as your data source and you're using purely historical data, you're not doing any data cleansing or data modeling with it, you are going to end up with a very skewed and a very biased data set. No matter how good your model is, you're still going to be making biased predictions and biased outcomes that come from it. A lot of cases similar to this. There are, however, interesting cases where it's not quite as black and white as that. US healthcare data, or any kind of healthcare data, is quite black and white in terms of how how the bias is built, because you can kind of see it just looking at a very high level that actually certain minorities are not very well represented within the data set. There is an interesting case around CoPilot. Hopefully some of you have had a chance to go look at CoPilot and know kind of what it is, but for those of you who are not aware, it's basically an AI assistant for writing code. So if you've used GitHub before, you have the ability to use CoPilot, and now GitHub being owned by Microsoft, this is all kind of underneath a Microsoft technology brand. Currently, there is a CoPilot case making its way through the US courts, and the reason why I bring this up is it could very well redefine how we collect data for machine learning. Typically, if it hasn't been stuff that is directly used for commercial use, generally it's kind of been okay for machine learning. People have kind of turned a blind eye. Whether that's right or wrong, I will leave you to go and decide. But this is going to define when copyright is enforceable. There are a lot of machine learning models that have been built on stuff like news articles that, funnily enough, come underneath copyright, or they've been trained on images that have been scraped through an image search engine. Once again, a lot of those images are subject to copyright. They aren't directly being used for commercial gain. You're not putting them as for sale. You're not using them as part of marketing material or anything like that. But when we start talking about generational models, so we're not talking just about decision making here, we're talking about stuff that is creating things. So this is when we're talking about things like GPT-3, CoPilot, as discussed before, DALL-E, just to mention a few. They can produce near copies, or in some cases, exact copies of existing work. If that is copyrighted work, does that not breach copyright? I don't think that doing something illegal is an ethical thing. So this kind of builds into a big snowball very quickly, where if we want to build ethical models, we need to actually go look at how we get the data, what that data is subject to as well, in terms of legal restrictions. And you'll be surprised at what legal restrictions are put in place. I'm not saying crash every model that's ever been built on these. There are some wonderful things that have been built using this, but it's worth thinking and it's worth keeping in the back of your mind as you're going creating these kind of models. There's also the danger that we have with convenience data sets. So this is actually a video of where I used to live. I've always been a country boy, as you can probably tell by the very much outsideness that's surround me, although it's a bit dark right now. I've grown up roads like this all the time. There's a real challenge with autonomous vehicles, is that nearly all the training data for an autonomous vehicle is actually urban data, or it's built or it's on all the motorways. Very little of it is done in rural locations. And driving in rural locations is vastly different. There are chickens in the road, there are no road markings. We even have to ford rivers, as you're about to see here. We have tractors overhanging onto the other side of the road. You have to go and avoid traffic by going up onto the verge. All things that would never happen in an urban or a motorway environment. So how do you train an autonomous vehicle to be able to cope with this? If you just dump an autonomous vehicle today into scenarios like this, they panic. They generally just stop and they stop working, because that's the safest thing to do. So I'm not saying that's a bad idea, but it's certainly not ideal. The challenge is when we go and create AI, what we're trying to do is generally create AI for good. We want to create AI for everyone. We don't want to create AI for the few who live in cities. So we need to think how we balance this. We also have the challenge that a lot of those data sets are built from Western scenarios. So we're talking about the UK, Germany, France, the US, Canada. If you take a autonomous vehicle, put it in the center of Mumbai, it's never going to move, because it literally will not know what to do, because how the driving works in India is vastly different to how it does over in Western cultures. Going even further than that, and I've talked about there just purely difference between urban and rural. What we can also do is when we talk about the different road users, there's an interesting article a few months ago by the American Automobile Association, well, by Forbes, from the American Automobile Association, that found that autonomous driving technology will hit cyclists in 33% of all tests. This isn't just a single manufacturer problem. This was with Tesla, this was with Hyundai, this is with Subaru. So we're not talking, oh, it's just, I know, Hyundai or whoever it is haven't quite got their tests right or haven't calibrated something. It is a problem across every single automaker. This is all because there is a lack of edge cases. They've trained it on stuff that is seen every day, which is great. But actually, that's not generally the danger. That's generally really easy to train on. The edge cases are where the real challenge happens. In fact, I was speaking to an autonomous vehicle company earlier this week, and I actually asked them, where are you currently driving? And they were like, oh, we're just doing European urban environments, but their goal is to cover everywhere. They're looking to do kind of deliveries and things like that. I was like, that's great, but I don't live in a city or a town. I live very much in the middle of nowhere. Your vehicle will not be able to ever get to me right now. So there is a whole thought process that goes into how we collect this data as well. We also have the danger of proxy variables. So I promise this isn't going to get into scary maths or anything like that. There are some percentages on the screen, but hopefully nothing to worry about here. Because what we have to do when we're building training data sets is we have to remove personal information from data sets. So that probably won't particularly surprise you. We can't have people's names and things like that in there for various reasons, most of them being privacy, but also we don't want to overfit models. The challenge we have is we end up with proxy variables in a lot of cases where a single variable might not be uniquely identifiable, but you take a series of attributes and you can uniquely identify people. So here I've taken a couple of examples. They're really, really powerful. So the first is we take 3 attributes. So 3 attributes that you typically find on a credit application. So you'll take an outward postcode. So this is the first part of a postcode in the UK. So this kind of just goes, this is the general area someone's in. We're talking, and sometimes that can be 50 square miles. So you're not talking anywhere particularly specific. Some areas, especially more dense areas, it's slightly less, but in rural areas like I am, it's quite a large area. Then you can take my birth date. That's not particularly surprising to if you're making a credit application. Someone needs to know how old you are because you can't lend to people who are too young. And there's obviously significant risk of income and things like that when people get older, and you don't want people having debt when they die and all those kind of good things. Then we also take my gender. So I'm male. With those 3 things, there is a 75% chance you can correctly identify me within what should be an anonymized data set. If we add the 4th variable, which is I'm full-time employed, not what my job is, just the fact that I am employed, that takes it to 89%. At that point, you're running into basically I'm not far off of guaranteeing you can identify people within a data set. And those attributes we're talking about here are nothing crazy. We're not talking about anything really unique. And they're very much things you'll find in a credit application. This becomes important because this is where we start interacting with legislation. GDPR is very much prevalent in Europe. Even if you're in the US, there is a high chance that you still have to comply with GDPR. It prohibits identifying unique individuals within a dataset without their explicit permission. And I would hazard a guess that most companies that are building AI models like this and using what they think is an anonymized dataset have not got explicit permission from customers that they can use their data for this use case. Once again, we go back to, if you're doing something illegal, it's very difficult for that thing to be ethical at the same time. In another example of a similar thing, different kind of technology stack, using an AI system, you can actually identify people from anonymized interactions of Bluetooth over 50% of the time. So a lot of the contract tracing apps that existed during the wonderful COVID years that we've just had use Bluetooth data to be able to go and ping where people are and be able to see who close contacts are. There was actually a study done, and with that data, which is meant to be truly anonymized, actually over 50% of the time you can select the specific individual. This causes, 1, ethical issues from legality, should we be identifying individuals and things like that. also causes you actually a model problem where, because you're identifying individuals, you can actually overfit a model. And that's not a good thing. We don't want to be overfitting a model because you're not going to get a very good result when you actually push that into production. In your test samples, it might be fantastic because actually you've built it on this data set. But in reality, you're just trying to map single data points to data points that are completely irrelevant. And that will be a big challenge to ever overcome. So what can we do? I'm not going to say there is a silver bullet here. There is certainly not a silver bullet to solve all of these problems. And I'm not going to say these are easy tick box solutions that magically will solve all of your problems. But there are 4 steps that we can kind of take. First is being aware. So good start, you're here. So that's a strong start to being aware of what's happening. Second is diversifying our data sets. Third is how we annotate. What is our annotation strategy? How do we get the best out of it? And the fourth is making sure humans are in the loop of this whole process. We don't just do AI as a pure technology play because it will not work. So the first step, being aware right at the very start. The best place to start is the data ethics canvas. And this isn't even AI specific. So even if you're not running an AI project right now, you're just running a general technology project, I would highly recommend you check this out. So this has various different things that are kind of pertaining to technology solutions, stuff like the right to use data. Do you actually have the permissions from the end users in a lot of cases that you can actually even use that data? As I was talking previously, a lot of these data sets, especially if they can identify individuals even through a proxy variable, you need to have direct permission from users to be able to use that data. There is a scary amount of companies that use data like this when they shouldn't do. And you don't want to be that person because when you get found out, it is incredibly bad publicity. And if we're honest, probably will cost you a job. And no one wants that. We also need to look at the negative effects. Let's imagine for a reason. So we're going to go straight into Utopia land because Utopia land is wonderful to talk about. So in this Utopia land, I'm developing an autonomous vehicle. It's fantastic. It literally never hits humans. It doesn't harm anyone. It knows exactly how to stay on the road absolutely perfectly. I am the world's best data scientist and I know exactly how to solve this problem and everything is wonderful. There are still negative effects of this. And these are sometimes a bit difficult for us to admit. You take that autonomous vehicle, if it's absolutely perfect, why do we need lorry drivers or truck drivers? Why do we need taxi drivers? You are going to make someone unemployed by doing that. That is a negative effect. This doesn't mean positive effects can't outweigh the negatives, but we just have to be honest and realistic that there are going to be some negative effects. There is virtually no scenarios, at least I can't think of a scenario, and if you can think of one, please do shout out. I'm more than happy to have these kind of conversations because they're incredibly interesting. Around a scenario where there are absolutely no negative effects, there is only positives. Also being open. Most of the AI industry and machine learning, especially as we start getting into deep learning, is we are quite often breaking new or pretty new ground when we're doing these things. There are scenarios that I've been through even recently where actually I can't find anyone who's doing this anywhere else in the world. It's interesting. It certainly keeps me on my toes, but we need to be honest about what we've done. We need to provide write-ups of how we've achieved this, give understanding to people, just tell people what the challenges are. If you're trying to do something that's never been done before, you will come up against challenges, and then give some explanation to what we've done. That doesn't mean you have to go and give all of your trade secrets away and you can't have any IP, but it means that when someone else wants to come and do something similar, maybe in a different industry to you, they have the ability and they have somewhere that they can start from. This has been incredibly successful so far, but it's something that needs to continue. And we can't go the other way where everything gets more closed. We also have different things that are more AI specific that you can use. So you've got the Turing Institute. If you haven't read some stuff by the Turing Institute, they're absolutely fantastic. Turing Institute, after Alan Turing. Hopefully you know who Alan Turing is because I'm not going to explain. But they have Project Explain. So this is around how you build explainability and transparency into AI systems. There is a big challenge right now where AI can become very opaque. It's very difficult for someone to tell why something has happened, and that starts breeding mistrust. As soon as someone just goes up to you and goes, the computer says, no, I don't know, I can't help you, you're immediately going to not trust that system, no matter what it is. No one likes being told no. And let's be honest, I don't like being told no. But if someone goes, we can't do this, this is the reason why, at least you can go, okay, I can kind of see that. And there might even be things that you can go and improve, and you can actually be accepted, or it might be a positive outcome next time. This doesn't mean, though, that it's absolutely perfect. There are certainly areas that you, in some cases, need to have a degree of opacity to, but it's finding that balance between the two. We also have things like the Responsible AI framework. So this is done by Google. It's great. It's a framework for development. So first off, this is not a checklist. It's not follow this and magically you are ethical and all your problems go away. But it is a really good way to start building and give you some good direction to where you should go. One of the really interesting pieces is actually how you look at building the team that's going to build this. Notoriously, and I've been in companies that are guilty of this as well, and I'm sure some of you have as well, there has been a very non-diverse group of people building an application or an AI system. If you have people from a very similar background, very similar upbringings, very similar demographics, they typically converge on roughly the same thought process. If you have people who are diverse, so you're talking people in different backgrounds, different cultures, sometimes different areas of the world, they have a very different view on how things should be done. And actually, that starts getting out some of that unconscious bias that we have, because people start challenging. And what needs to happen to get rid of bias is challenge. There's also legislation coming in. So whether you like it or not, you might be pushed in a direction to start doing this. So the EU has a proposed legal framework for AI development. They've also proposed legislation for harmonized AI. If you're an American, you might think it's not relevant to me. I don't have to worry about it. It's EU legislation. If you deal with any entity in Europe, so this could be a business, it could be a person, you have to comply with this. This is similar to GDPR in anything that deals with Europe, it has to comply with. The problem is it becomes even scarier. GDPR, for those who are not aware, the maximum fine is 4% of revenue, and this is global revenue, not just European revenue. The actual fine for breaching these frameworks and this legislation is set to be 6%, so a 50% increase on what it is for GDPR. So it is getting to be a quite scary number for a lot of people. So you might be kind of pushed down this route. So why not get ahead of it? This is where we're trying to go. How can we get you ahead of these things so you're ready to go when you need to? The next step is building your own data set. So earlier on, I was talking about the dangers of convenience data sets and how they can not necessarily be perfect. So convenience data sets are data sets that are super easy to get. So this is the stuff that's quite often open source, or you're just grabbing stuff off of an image search engine or something like that. They are very Western focused. If you're building an AI system that needs to be truly spanning the globe, you are going to be incredibly biased towards the West at that point. In some cases, detrimentally so. I will caveat here saying facial recognition is very up for a debate of whether it's an ethical thing or not. But let's say we found a good ethical use case for doing facial recognition. A good data set to start with, and a lot of people do, is labeled faces in the wild. Great data set, super useful for providing at least a beginning. The challenge we have here, as you can probably see from that image, is 78% of these faces are male and 83% are white. I don't know the current stats, but the last time I checked, that's not the breakdown of the world's population. In fact, very far from the breakdown of the world's population. And the reason why quite often these are used is because they're the easiest thing to get. They're super easy to go and grab and start with. And I'm not saying don't do that. What you should do is when you're doing that proof of concept, so that first stage, yeah, go grab a nice easy data set to use. See if the concept even works as a theory. Once you've got to that point, you're going, cool, this concept works. We've got buy-in from the business. We now need to go and create our own data set. We need to go and annotate our own data set that is actually going to be useful for the specific use that we've got. It might even be that you build on top of data sets like this. Once again, completely valid thing to do. But what we're doing is curating additional layers on top of it that are going to be relevant specifically to what you want to go and deliver out to the market. Then we need to look at how we annotate that data. Traditionally, data scientists have talked around more data is just better. Flat statement. Just give me more data will solve all the problems, because their models are fantastic, and with hyperparameters and all these kind of weird, wonderful things they can go and tweak, they can solve all of the problems in the world. That's not entirely true. If you give a model more bad data, to a point you can make it better, but you reach a ceiling very quickly. It doesn't magically solve all your problems. It doesn't magically solve biases. Knowing what extra data you need is incredibly useful. When we work on projects and we're trying to build out AI models, what we like to do is work on an active learning approach. So you have a system that's consistently looking for items in the unlabeled data set that there is confusion on. So it goes, okay, we're not entirely sure on what this is. Can we go pull this to the front? And those items being annotated, that's where you're going to get the greatest value. We've actually seen to get to the same level of accuracy, if you just randomly label data compared to doing an active learning approach, you can actually reduce the amount of data you need to get to the same accuracy level by 80%, which is a big impact on how quick you can get to production in a model, and also the cost, frankly. All of this takes time and money to be able to go and deliver. Instead, what you can start doing is putting all that effort into focusing on, okay, how do I get to the next level? How do I go from, okay, this model is pretty good to this model is excellent, and also this is getting rid of some of the challenges that we have. Also, when you're labeling data, don't do everything automatically. We want to have humans involved with this process. You will see on the far right hand side, that's actually an image from Newfoundland of a Newfoundland dog. I mean, a statue of one, but dog nonetheless. And with a reasonable degree of confidence, we're talking near 70% here. So we're not talking something that's a complete outlier here. It thinks that's a bird, and I think we can all reasonably confidently say it's not a bird. It's probably a dog. We also have the other ability where we can have an AI assistant go and actually help annotators. So you'll have humans go and sometimes verify things, and this would depend slightly on the approach you want to take. So you could have humans go in and verify the annotation the system's done, or you could have humans annotate stuff and the AI come in and go, actually this might be missed, or this actually might be in the wrong class, or actually this might be the shape of it, and you do that comparison. Either strategy works. Sometimes you can combine the two, depends on what you're trying to achieve. But looking at that strategy is actually really important, because that can save you a lot of time, money, and effort in getting to where you want to get to. We also have the handling of exceptions. So in a lot of cases, and I've seen this more times than I would probably care to mention, we have customers who are running inference at the edge, and that's great. They're predicting stuff, and most of the stuff, we're probably talking 90, 95, sometimes even higher than that percent of stuff. Prediction is spot on, absolutely get stuff right. Actually, it's the last 5-10% that is really important. Actually, that challenging stuff is what should be sent back. In a lot of cases, and slightly worryingly, this is normally discarded. Actually, you want those low confidence items to become the new training data set. You want those new items to be brought to the front. It's the same thing we were talking about previously, but in a later on stage. where previously you're talking about building that initial training data set, bringing those items to the front. When you're talking about live production, we want to be continually bringing those exceptions back into the fold, back into training data sets. We want to be retraining consistently. Anyone who tells you you can build a machine learning model and just let it sit has probably never built a machine learning model in their life, because there's stuff like model shift. So model shift is the concept of the reality of the world that the model exists in changes over time. And if you go back a few years ago, stuff like TikTok didn't exist. So even small changes like that can make a big impact. If you are doing stuff that's looking at how you, filter web traffic, if you didn't know that existed and that's now consuming a vast amount of bandwidth, a model wouldn't know how to handle that. So you've got to be thinking about these things consistently. The world changes. Even small changes can make big differences to what you're building models about. You also need to not only rely on technology for explanations. So we touched on this a little bit before, but this is the concept of explainable AI, or XAI. I will say early on and early doors, this doesn't mean you should not use XAI. In fact, I would say that XAI is complementary to what we're talking about here. However, I've seen a lot of people who will believe XAI solves all ethics problems, and it doesn't. I speak to a lot of people around this topic from a lot of different countries, and whilst XAI has its place within the ethics piece, do not believe that it will solve all the problems. It's really useful for pointing you in directions of things. So if XAI was basically saying the points how it's actually going through the neural network and how it's actually picking out certain elements and certain features, and it's really struggling with certain classes, you might actually go, well, if it's struggling with certain classes completely, it's probably something data related. So it'll give you some kind of direction on those kind of things, and that's useful, and it's good as a starting point, and it's something that should be built in, because this is when we're talking about, we want to get away from computer says no and computer doesn't understand. It's computer doesn't understand because, or computer says no because. Those things are really useful. The challenge is, as soon as XAI gets somewhere near being up to date, there's a whole new load of models and way more complex models that exist. And we are talking now about multi-layer models that have a load of hidden layers that actually, in some cases, there's nearly dark arts involved with trying to get stuff through there and actually the understanding out of it. So it's not an easy problem to solve, and I don't envy the XAI developers and companies delivering XAI. It's certainly not easy. And in some cases, it can mean that you can't train quite as consistently because you need to have that explainability built in. So as with everything, there is a balancing act of trying to get this stuff working smoothly and cleanly and efficiently together. But a little bit about CloudFactory. So CloudFactory are a data services partner. We work with over 600 companies across the world, and we've been doing this since 2010. So we're certainly not a new player in this market. We've delivered over 25 million hours of data labeling expertise to those companies. And actually last year, we've delivered nearly 7 million hours just by itself. We are very much focused on stuff like positive customer experiences, but also positive cloud worker experiences. So we want to make sure that we are serving both our clients as well as our team. What we've found, and especially when it comes to the scale of operations that a lot of our customers are working at, is you want to have a team that is motivated to work. I'm sure all of us have been in jobs where we don't want to be there and it's something we're not particularly enjoying. You don't necessarily produce your best work. So what we want to do is we want to invest in individuals, communities, and then that means we immediately give back better to our customers. This is very much reflected in our NPS score. 62 is actually pretty damn high for any kind of tech company that exists. And actually, most customers are expanding with us within the first 6 months because of the work that we do. We also have a sister organization that focuses on data labeling platforms, building out machine learning models as well. So loads of really interesting stuff that we certainly do within this space. Most importantly to us is we are a mission with a business, not a business with a mission. And our mission is to create meaningful work for 1 million talented people in developing nations so they can earn, learn, and serve on their way to become leaders worth following. So thank you. That's kind of the end of where I am. If you do want to reach out to me, drop me an email. You can find me on LinkedIn. I'm more than happy to have conversations within this area. If you do have questions, drop them in and I will more than happily answer them right now, or if you want to email them to me later on so we can have a more one-on-one conversation, that is equally more than fine.
Thank you, Matt. I think you've provided people with a lot to think about. Thank you, everyone, for joining Matt during the presentation today. Please do catch up with him via email, as shown today, or on LinkedIn. I'm certain that they would like to continue that conversation. Thank you for joining us, everyone. Bye, Matt.